In today's class, we are going to start with chapter 4, rational numbers. Now, let us understand what is a rational number. A number that can be expressed in the form of p upon q, where p and q are integers and q is not equal to 0 is called a rational number. You all know about integers. There also we write in p upon q form. Here also the difference is here that we have p and q both integers here. It means they can be positive as well as they can be negative. Alright. Here 2 upon 3, minus 3 upon 5 or minus 4 on 7, 0, 1 on 2, all are rational numbers. Now let us understand few properties here. 0 is a rational number. 0 because 0 can be written as 0 upon 1, 0 upon 2 and so on. Next, every natural number is a rational number. Now every natural numbers means 1, 2, 3, 4. How are they rational numbers? Because they can be written as upon 1, 1 upon 1, 2 upon 1, 3 upon 1, 4 upon 1 and so on. Next we have every fraction is a rational number, that all of you know. Fraction means numerator upon denominator. So let us take example here, 2 on 3, 5 on 6 and so on. We can take as many examples as we want. Okay, all these are rational numbers. Every integer is a rational number. Now all of you know integers means minus 3, minus 2, 2, 3. Now how are they rational numbers? Because we can write upon 1 to each integer. Alright. So these are examples of integers as rational numbers. Next we have positive rational numbers. A rational number is said to be positive if its numerator and denominator both either positive or both negative. Means if both numerator and denominator are of same sign. 2 on 5, minus 10 on 3, because negative sign cancels with negative sign, so it will be a positive rational number. Alright. So 13 on 9, minus 41 on minus 39, all are examples of positive rational numbers. Next we have negative rational numbers. A number is said to be negative if its numerator and denominator have opposite signs. Minus 2 on 3, 4 on minus 7. So negative sign can be with numerator or with denominator, but one will be positive and one will be negative. Then we will have negative rational numbers. Next we have absolute value of a rational number. If p upon q is a rational number, then absolute value of p upon q is written as absolute value. We know we write it in bars, p upon q. Now it will be equal to absolute value of p upon absolute value of q. We will write the absolute value of numerator and absolute value of denominator separately. So here let us take this example, 3 upon 7, its absolute value will be equal to absolute value of 3 as well as absolute value of 7. Now we know absolute value means always positive value, so it will be 3 on 7. Similarly, absolute value of minus 7 on 6 will be equal to absolute value of minus 7 upon absolute value of 6. We know absolute value of a negative number is always positive, so it is 7 upon absolute value of 6 will be 6. So 7 upon 6 is our answer. Next we have equivalent rational numbers. Two rational numbers are said to be equivalent if one of the rational number can be obtained from the other by multiplying or dividing numerator and denominator by the same non-zero number. Means if in a rational number numerator and denominator both we either multiply by the same number or we divide by the same number. The result that we will get, that will be an equivalent rational number to the given number. Now let us take this example, equivalent rational number of 5 on 6. Now if numerator 5 and denominator 6, we either multiply like this, that is we get here 10 on 12. Alright, so 10 on 12 is a equivalent rational number to 5 on 6. We can take more also, 5 on 6 into 3 above also into 3 below also. So we get 15 on 18. Now 15 on 18 is also equivalent rational number to 5 on 6. So we can say 5 on 6, 10 on 12, 15 on 18 all are equivalent rational numbers. Alright, now let us discuss few properties here. If p upon q is a rational number and m is any non-zero integer, then p upon q is equal to p upon q into m, q into m, p into m. So both will be multiplied with same number, same non-zero integer. Alright, let us take this example, minus 7 on 9. It means minus 7 and 9 both can be multiplied with same non-zero integer. So if I multiply it with 3 here and 3 here, so I will get here minus 21 on 27. It means m is 3 here, the number with which we are multiplying. Okay, so numerator and denominator both can be multiplied with same number. Then p upon q is a rational number and r is the common divisor of p and q. It means p upon q both can be divided by the same common divisor. This is an example, minus 15 on 10. Now 15 on 10, we know both can be divided by 5. So minus 15 divided by 5, 10 divided by 5. So we get here minus 3 on 2. Okay, and here r we have taken as 5, the value with which we divide it. Alright, now let us start with exercise 4.1. First question is, write down numerator and denominator. Now the the rational number is 0 upon 3. Numerator here we can see is 0 and denominator is here 3. Next part, minus 1 on 3. In this rational number, numerator is minus 1 and denominator is 3. All of you understand this thing. Which of the following are not rational numbers? Now we know rational numbers which can be written in numerator upon denominator form, and numerator and denominator both can be negative or positive. Alright, so 3 on 2, yes, this is a rational number. 0 on 7, yes, we know 0 is a rational number. Minus 2 means we can write it as upon 1. So this is an integer and we know integers can also be written as rational numbers. Now 4 on 0, in denominator 0 is not possible. Alright, so we can say that 4 on 0 is not a rational number. Rest 2 on minus 5 and 1 on 9 all are rational numbers. So the number 4 on 0 is not a rational number. Alright, next question number 3 is, write a rational number whose numerator is equal to 3 and denominator is equal to minus 7. Now we know rational number can be written as numerator upon denominator. So we will write it here as 3 as numerator and denominator as minus 7. So our rational number is 3 on minus 7. Question number 4. Express minus 4 on minus 7 as a rational number with denominator minus 28. So how we will change denominator minus 7 to denominator minus 28? It means if minus 4 on minus 7 It means 7 minus 7 if we multiply with 4. Same number we will have to multiply with numerator also. Alright. So we will get here minus 4 into 4 as minus 16, minus 7 into 4 as minus 28. So this is the rational number minus 16 on minus 28 with denominator minus 28. Alright. So how we have chosen here minus 28, we have selected the number by multiplying which with minus 7 we get answer as minus 28. The same number we multiplied with the numerator also. Alright, I hope you have understood this. Next question is express 6 on minus 11 as a rational number with numerator minus 6. Here numerator is 6, but we want numerator as minus 6. It means minus 1 is to be multiplied with this 6 to get numerator as minus 6. Alright, so 6 into minus 1 here we will do, because we want result as minus 6. Alright, but minus 11 is there, so it should also be multiplied with minus 1. So we get answer as minus 6, and here minus minus will become positive, so it will become 11 only. Alright, and if we want to change 6 upon minus 11 as a rational number with numerator 30. Now what should be multiplied with 6 to make it 30? It is 5. 6 5s are 30. So same 5 we will multiply with denominator also. So we get here 30 on minus 55. So 30 on minus 55 is a rational number with numerator 30. Alright. Question number 8. Write as a positive denominator 6 on minus 7. We can change the sign by multiplying the rational number with minus 1. When we want minus 7 to be changed to plus 7, it means 6 on 7. 6 on minus 7 should be multiplied with minus 1. So same minus 1 we will have to multiply with 6 also. So minus 6 on 7 is the positive denominator 7. Alright. Then minus 3 on 5. It is already positive. So it will be minus 3 on 5 only. Next, write 3 rational numbers equivalent to minus 7 on 8. Equivalent rational numbers, as I told you above, we will multiply the rational number, both numerator and denominator, with same number. So we can get by multiplying with 2, 3 and 4 we can take. Above and below both we will multiply with same number. So here 7 2s are 14. It is minus 14 on 16. Then 7 3s are 21. So minus 21 on 24. Here 7 4s are 28. So minus 28 on 32. So we can say these three are equivalent minus 7 on 8. Now let us start with question number 10. Find equivalent forms of rational number having a common denominator for numbers 3 on 8 and 5 on 7. Now we want a common denominator. Here we can see 8 and 7. So here we do not have any common divisor of these two numbers. So what we will have to do, we will have to take LCM of denominators. Alright. So we will take LCM of 8 and 7. LCM of 8 and 7 will be equal to 8 into 7, that is 56. Now means here we can change 8 to denominator 56 by multiplying it with 7, and same 7 we will have to multiply above also. Alright, so we get here 21 on 56. Now next number is 5 on 7. Now it means this 7 is to be multiplied with 8 to make it 56. So same 8 we will multiply with 5 also. So we get here 40 on 56. Now we can see 21 on 56 and 40 on 56 are two rational numbers with the common denominator 56. This is the way we will do this question to get the common denominator. So children, same way you can do the remaining parts of this question as well as all previous questions. So you will complete your exercise 4.1 in your registers. Alright. Thank you children.